All right, using OpenStack's textbook Calculus Volume 2, we are working on trig substitution, and here we have another example of an expression including the square root of a squared minus x squared. We are going to, gotta go back, yep. We're going to use this when our a is 2 because our a squared is 4. So we're going to say x equals 2 sine theta, which means that, just for future reference, because we're going to need it, x over 2 is sine theta. We also know that dx is 2 cosine theta, d theta. We're also going to use the fact that since sine of theta is x over 2, this is our reference triangle. All right, come over here, integrate. 4 minus, I'm going to go ahead and square the 2 sine theta when I put it in. Just saves a step later. All over 2 sine theta times 2 cosine theta d theta. So right here, we are going to 4 times 1 minus sine squared, which is 4 times cosine squared. So we have the integral of 2 cosine theta times 2 cosine theta d theta over 2 sine theta. Sorry, that pen thing messes me up every time. All right. So up here, I'm going to have 4 cosine squared theta, but the 4 and the 2 here are going to simplify. So we have 2 cosine squared theta over sine theta. And even though it seems kind of counterintuitive, like we're undoing stuff we already did, we're going to use 1 minus sine squared theta. All right, integral. I'm going to distribute my 2 here. 2 sine squared theta. So we have 2 over sine theta minus 2 sine squared theta over sine theta d theta. We're going to need to come back up here for more room. That would be 2 cosecant theta using reciprocal identities, d theta, minus, here the sine and sine squared simplify, so we have 2 sine theta d theta. Well, the integral of cosecant theta we saw earlier was 2 from there, ln absolute value of cosecant theta minus cotan theta, minus the integral of sine theta is negative cosine, so we're going to make that a plus 2 cosine theta, not d theta because we got rid of that, plus c. All right, back to our reference triangle because we need to replace cosecant, cotan, and cosine of theta. Adjacent, opposite, hypotenuse. Cosecant theta is the reciprocal of sine, so that's going to be 2 over x. Cotan theta is adjacent over opposite, so square root of 4 minus x squared over x. And cosine theta is adjacent over hypotenuse. So we're going to have 2 ln absolute value 2 over x minus square root of 4 minus x squared over x plus 2 times the square root of 4 minus x squared over 2 plus c. These 2's are going to cancel, and that's really my answer now. There's not a lot. You could get a common denominator. You have a common denominator. You could put that together, but there's really no need. So if I wanted to, I could write it as 2 minus square root of 4 minus x squared over x plus square root of 4 minus x squared. Let's see. Final answer. All right, let's do one more of these. looking at the square root of a squared minus x squared again, using the square root of 1 minus x squared. Now we have that extra x to the third sitting there as well. We're going to deal with that as it comes. But for right now, we're going to say that since my a is 1, x is going to equal 1 sine theta, which means that sine theta equals x over 1. We know that dx is going to be cosine theta d theta. Our triangle is going to be x over 1. This is going to be the square root of 1 minus x squared. All right. So we have the integral of sine to the third x, nope, theta, not x, theta, square root of 1 minus sine squared theta times cosine theta d theta. Ooh. All right. This is the Pythagorean identity. I don't have to do anything to it. So I'm going to take the square root of that. We have the integral of sine to the third theta, cosine squared theta, because this one's going to come out as cosine times cosine, d theta. Using the rules from the previous section, since sine has an odd power, we're going to replace it with sine squared theta times sine theta. And we're going to break sine squared theta into 1 minus cosine squared theta. And this is the sine theta that was left over. All right, we're going to distribute and have cosine squared theta minus cosine to the fourth theta, sine theta, d theta. We're going to use u substitution. U is cosine theta. Du is negative sine theta d theta. We need a negative here, so a negative out here as well. So we have negative 1 integral u squared minus u to the fourth du. So negative 1 of u to the third over 3 plus, because when I distribute my minus, cosine to the fifth over 5 plus c. Now, we've got to go back and fill in for cosine. Cosine theta is going to be the square root of 1 minus x squared over 1. So we're going to have negative cosine to the third, which would be square root 1 minus x squared to the third over 3 plus square root 1 minus x squared to the fifth over 5 plus c. So a lot of times they'll take this, and instead of a square root to the third power or square root to the fifth power, they will make it 1 minus x squared to the 3 halves and 1 minus x squared to the 5 halves. Same thing.